All right, so in this lesson, we're going to be talking about angles. We're going to be talking about measures of angles, how to name angles, stuff like that. All right, so like our lines and rays and stuff like that, we have specific notation on how we name an angle. All right, and we're going to talk about the different ways we name an angle, but first I want to talk about notation. All right, so if you guys see this symbol, all right, so let's just say angle ABC for the sake of this. This is talking about the name of the angle. All right, so that's all they're talking about, is just the name. However, if you see an M out in front, they're talking about the actual measure of the angle. Okay? All right, so this one's just the name, whereas this one is talking about the actual measure of the angle. All right, so let's talk about how we name angles. So we can name angles by using numbers. We can name angles by using one letter, or we can name an angle by using 3 letters. Now let's take a look at number 1. So number 1, I have this angle given to me. Now there's 4 different ways that we can name this angle. Now, as you guys can probably tell, that there's a little 3 in the vertex of the angle. So the vertex, really quickly, is just like the point of where the 2 rays meet. All right? So one way we can name this angle is angle 3. Another way we can name this angle is angle D by the vertex, because D is at the vertex of the angle. Now I said we can either name this angle by using 1 letter or 3 letters. So another way we can name this angle is angle CDE. Another way we can name it is angle EDC. Okay. So we can go EDC or CDE. All right. Well, let's look at 2. So again, 4 different ways that we can name this angle. We can name it by using a number, so angle 4. We can name it using 1 letter, the vertex angle. So angle F. We can name it by using 3 letters, so G, F, E. And we can name it E, F, G. Okay. Now, let's look at the next part. So the next part's a little different than this part. Now, I need you guys to understand the difference of when we name like this angle versus this angle. Okay, so in this angle, there's only 1 angle with a vertex F. However, there's 3 different angles, or multiple different angles that has V as the vertex. So how we name these angles is a little different how we name this angle, but let's talk about it. So we want to name all the angles that have V as the vertex. Okay, so here's some numbers. Now V obviously is this point right here. All right, so we can name one of the ways that we can name this angle is angle 5, because there's a number right in here. We can name this angle 6. Now, as I just talked about, there are multiple different angles at vertex V. If you tell me angle V, I'm not going to know what angle you're talking about, right? So that was why we could use angle F for this one, and why we cannot use just angle V for this one. All right, so for this one, to name all the angles that have V as a vertex using the letters, we have to use at least 3 letters. Okay, we can't use just 1. All right, so one angle we could say is JVI, but we could also say IVJ. We could say angle V, no. We could say angle HVI, or we could say IVH. We could say angle JVH, and we could say angle HVJ. Okay. All right, so now let's look at 4. So 4, there are 3 different angles at with vertex V, but they're still the same process. We cannot use a single letter. We have to use either 3 letters or the numbers that are in the vertex of the angles that are labeled on our diagram. All right, so one of the ways we could name an angle that has V as a vertex is angle 3. We could say angle 4. We could say angle 5. We could say angle CVF. We could also say FVC. We could say angle CVD, so CVD, or we could say DVC. We could say angle DVE, or we could say EVD, so EVD, DVCE, or we could say FVE, or we could say angle EVF. We could also say angle CVF, so CVF, oh, I already got that one, never mind. All right, I think I got all of them. All right, so now you guys have to be careful for when we're talking about congruency versus equality. So when we're saying 2 angles are congruent, we are only using the name. So let's take these 2 angles. Now these are the same exact angle, but I just want to show you the difference between when we say 2 angles are congruent versus when we say 2 angles have equal measure. All right, so we can say that CVD is congruent to angle DVC. So I'm only using just the angle symbol, not the M. Now, if you want to say they are equal in measure, we use the M one now. So the measure of angle CVD is equal to the measure of angle DVC. Okay, so now we're talking about measures and numbers, then that's when we use equality, an equal sign versus a congruent sign. All right, so let's go on to the next page. All right, so you guys are going to see a lot of acute, right, obtuse angles in geometry, I believe. I mean, you guys may or may not already know what these are, but let's talk about them. So acute angle is an angle that has a measure less than 90 degrees. A right angle has exactly 90 degrees. Now, a lot of the time, you guys are going to see like this little box in the corner of the angle if it is a right angle. So kind of like pay attention to that as well. All right. And then obtuse angle. So an obtuse angle is an angle whose measure is greater than 90 and less than 180. Now there's another angle on here, or at least that should be on here, that is important. It's called a straight angle. And a straight angle is an angle whose measure is exactly 180 degrees. This is also a line, right? A line has a degree measure of 180 degrees, and which is called a straight angle. All right. All right, so 5, 6, and 7, we want to draw and label an angle to fit each description. So for 5, we want to draw an obtuse angle, and we want to call it angle Y. So an obtuse angle looks like that. It is greater than 90 degrees, but less than 180. Now, wherever we name our angle, whatever angle we're talking about goes in our vertex. So we call it like that. An acute angle is smaller than 90 degrees. Now, here's the thing. When we're talking about angles, the letter, and we have 3 letters, the letter that is in the middle goes to the vertex of the angle. Okay, so the middle letter is the vertex of the angle. All right, so that's an important thing to note. All right, number 7, they want us to draw a straight angle CDE. So straight angle looks like this. All right. All right, so I'm not going to go through each of these. I'm not going to do 3 examples of this. However, I do want to show you so you guys can kind of start seeing some constructions. Now, throughout the year, we're going to be doing a variety of constructions every so often. You will have a construction on the regions. So I just wanted to get you guys thinking about this. If you don't have a compass with you, that's totally fine. But I just wanted to kind of show you so you guys can get an idea of what it looks like. So this particular construction is copying an angle. So I'm just going to do number 8. So the first step in copying an angle is putting your vertex point on, no, I lied. What I'm going to do first is, no, I'm fine. Okay, never mind. Ignore me. Put your compass point on point M, and you guys are gonna draw an arc so that it hits the rays both times. So it's gonna hit the ray here, and it's gonna hit the ray here. Now, without changing my compass, I'm gonna put it on the end point of this ray they drew for us, and I'm gonna do the exact same thing here. Okay. Pretty light. I don't know if you guys can see it. It should be better. All right. Now I'm going to take my compass and now measure the distance. So at these 2 points where this arc that I just drew intersected those rays, I'm going to measure that distance out with my compass. Okay. Now I'm going to take my compass and I'm going to put my compass point right here. And I'm going to make a little arc so that way it intersects the other arc that I drew. And now I'm going to take my straight edge and I'm going to draw the other ray of the angle, other side of the angle. Okay, so that is a copying an angle construction. We're going to come back to this a little bit throughout the year. All right. All right, so let's take a look at the next page. All right, so these next 2 pages we're going to be talking about the angle addition postulate. So it's kind of like the segment addition postulate. So if you guys remember, like we talked about, the part plus the part is equal to the whole. Okay, so basically what they have in this diagram, so they have angle QRT, which is 40 degrees, and angle TRS, which is 83 degrees. So they're doing 40 degrees plus 83 degrees is equal to 123 degrees. So QRS is going to be 123 degrees because this angle plus this angle is going to form this whole angle. All right, so the measure of angle QRT plus the measure of the angle TRS is going to equal the measure of angle QRS. Okay? So essentially, we are going to do this for the rest of the examples. So let's take a look at 1. So we're going to find the measure of KLM if KLB, so this angle is 26 degrees, and the measure of BLM is 60 degrees. Okay, now like we just talked about, so the part plus the part is equal to the whole. So the measure of K angle, so the measure of angle KLB plus the measure of angle BLM is equal to the measure of angle KLM. Okay, so the measure of KLB is 26 The measure of BLM is 60. So 26 plus 60 is going to give us the measure of angle KLM. So that's 86. Okay? All right, so let's look at number 2. So we're going to find the measure of FGH if FGB is 105 and the measure of BGH is 54. Okay, so the measure of this plus the measure of this is equal to the whole thing. So essentially we're doing 105 plus 54 is equal to the measure of angle FGH. So 105 plus 54 is 159. Okay. All right, so let's look at 3. So the measure of GHC is 60. The measure of CHI is 104. We want to find DHI. So again, we're doing 60 plus 104 is equal to the measure of angle GHI. So the measure of angle GHI is 164. All right, so let's look at 4. So the measure of, so we want to find the measure of WVU if ZVU is 62 and WVZ is 50. So the measure of angle WVU is equal to 62 plus 50. So the measure of angle WVU is equal to 112. Okay, so number 5, so FMN is 99, LMF is 36. We want to find LMN. Again, we're doing 99, part plus part is equal to the whole. So 99 plus 36 gives me the measure of angle LMN. So 99 plus 36 is 135. Now this one's a little different, so let's take a look at it. So find the measure of WDC, so this one. If EDC, so this whole angle is 145, and the measure of EDU is 61. So you guys have to be careful with this one. Okay, it's the measure of angle EDW, plus the measure of angle WDC. That is equal to the measure of angle EDC. Okay, now EDW is 61. This one we want to find, and then this one is 145. So to solve for x, to find the measure of WDC, we minus 61. So x is equal to 84. Or the measure of angle WDC is equal to 84. All right, so let's go to the next page. All right, so let's look at 7. So 7, we have the measure of FCD is equal to x plus 41. And the measure of BCF is equal to x plus 78. So x plus 78. And the measure of BCD is 95. So we want to find x. So same concept, part plus part is equal to the whole. So this angle plus this angle is equal to this whole angle. Okay, so x plus 78 plus x plus 41 is equal to 95. All right, so we have 2x plus 119. Okay, so minus 119. Now this one's weird. It's going to give us a negative number. That's okay. if you guys want to go back and plug it in for x to check that this angle plus this angle is 95, then you're more than welcome to do that, but this is the right answer. Okay. All right, so let's look at 8. So we want to find x if the measure of angle LMN is 135. The measure of LMV is -1 plus 45x. And the measure of VMN is 23x. Okay, so again, same thing. Part plus part is equal to the whole. So -1 plus 45x plus 23x is equal to 135. Okay, so now let's simplify and solve for x. So we have -1 plus 68x so plus 1 plus 1. So x is going to equal 2. All right, so let's take a look at this one. So like I kind of explained on the previous page or the page before that, throughout the year you guys are going to do some constructions as we go. However, I believe there is going to be an angle bisector question on your first test. So this one I really want to be sure that I do an example for you so you guys kind of know how to do one. All right, it's not too bad. So the first thing we do when we do an angle bisector construction is we put our compass point on the vertex of the angle. So I'm going to use this angle. Okay. And we draw an arc like that. Okay. Now, where this arc intersects the rays of the angle, what I'm going to do is I'm going to measure that distance out. Okay. Now, what I'm going to do next is I'm going to draw an arc here. Like that. All right. And I'm going to flip it around without changing the size of my compass. And then I'm going to do the exact same thing on this side. Okay. So it should look like that. Now what I'm going to do is I'm going to take my ruler or straight edge. I'm going to line up where these two arcs intersect and where my vertex of my angle is. And then I'm going to draw a line down straight the middle. Okay? And that is an angle bisector. We're going to do a couple more in class next week, but again, just so you guys can get an idea of what an angle bisector is and how to construct it. All right, so let's take a look at 9 and 10. So we have a couple examples. Now, these little markings here in the angle tell you that they are congruent. So if you see these little angle markings, if you will, again, that tells you that they are congruent. So since they are congruent, this XP, this segment XP, does what we call bisects the angle YXZ, excuse me, YXZ. Okay, now bisect, remember, cuts something in half. So bi means two, sect means cut. So XP is the angle bisector, it cuts the angle in half. Now, as we talked about with the segment bisector, a segment bisector goes through the midpoint of a segment. However, an angle doesn't have a midpoint, right? So all the angle bisector does is just cut the angle in half. All right, so let's write that down so you guys know what it is. Okay, so it cuts an angle into two congruent parts. All right, so let's look at 9. So find x if the measure of angle 2 is equal to 4x plus 5, and the measure of angle 1 is equal to 5x minus 2. Now, as I told you, since these two angles are congruent, they're equal, these two things are equal to each other. So to set up our equation, we're going to set these two expressions equal to each other. Now, we can't always assume that the angles are congruent. So you either have to be told, like in this one, that something bisects the angle, or you have to be told in the diagram, you have to be shown in the diagram that those two angles are congruent. All right, so now we have 7 is equal to x. So our question asks us for x, so this is my answer. All right, so let's look at 10 quickly. So in triangle BCD, BP bisects angle DBC. So since this, we were told that this bisects this angle, then angle 1 is congruent to angle 2. All right, so now the question wants us to find the measure of angle 2 if the measure of angle 2 is equal to 7x plus 5, and the measure of angle 1 is equal to 9x minus 5. So since 1 and 2 are equal, we're going to set these two expressions equal to each other. So you get 10 is equal to 2x, so x is equal to 5. However, we are not done. They want us to find the measure of angle 2. So what we're going to do is we're going to take 5, we're going to plug it into this expression. So the measure of angle 2 is equal to 7 times 5 plus 5. So we get 35 plus 5. So the measure of angle 2 is equal to 40 degrees.